Hey coders, and welcome to episode 2 of our lock service playlist on the Google Apps Script course. In this video, we're going to be learning about how to create and implement a lock. So, having a lock in your code can prove to be vital for its successful execution. And again, you would want to have a lock, say, if you needed a certain section of code to complete thoroughly before a second instance of that code can be run. So we're going to see an example of that very shortly, but Google Apps Script has provided 4 methods for you to help you create that lock. They are try lock, wait lock, has lock, release lock. And we're going to look at those 4 methods in this video right now. So let's swivel on around to the code and see these methods in action. To demonstrate lock service, I've gone out and built a web app, which is actually a very common scenario why you would want to utilize the service of lock service. So let's just quickly go over what I have written down so far. We have this document right here, this HTML document, and by the way, here is the CSS, just in case you were curious on how it was stylized. But anyways, this document has an input field and then also a button. So let's see that rendered, and here it is right here. We have again our input field. Someone can type in, say, a name like David, and then they can hit the sign up button. And then once that button is hit, again, that button has an event listener, and once it is clicked, then it runs this callback function right here, in which it gets the value of the input field, and then it passes that value into the server-side function add name to database, and it runs that server-side function. So let's take a quick look at that server-side function. It's extremely simple. All it's doing is it is getting access to a spreadsheet, and then it's writing the value of that input field and then also a timestamp to that sheet. And it writes it and the last row +1. However, you may have also noticed this line of code right here. So this is an extremely simple function as it is. However, sometimes your functions are not as simple as this, right? So they may be a little bit more complex. After you get some data, after you receive some data, you may want to do some additional calculations on that, or you may want to make some additional network calls. And all of these things take time, right? So I've gone and simulated that. I've said, all right, let's say we have some additional logic, and that takes around 3 additional seconds to do. And then finally, we can write the data to the database. So that is what this line of code is representing. So let's just go and run this web app. So we'll hit David, or we'll type in David, and then we'll hit the sign up button. We'll go into our sheet right here, and there we go. After 3 seconds, we have gotten the name of David, the record right here, and also the timestamp. And it says 4:38 and 46 seconds, which is exactly the time right now. Great. So everything is working as intended. The developer is happy. Everyone is happy. However, what you will probably want to do is when you publish a web app, you'll want to have it accessible to many users, right? So, and that's why you would put it on the internet, right? So, there is a possibility that 2 or more of those users could be accessing your web app at the same time, right? Especially if you are allowing access to your web app to a great many number of users. So let's just say that we have someone like Jennifer, and she is trying to access the code, or she's trying to access this web app someplace on her own laptop. And then we also have, say, John also accessing the web app from his laptop, let's say in a different state, and they're both accessing your web app at the same time. Right, so let's say Jennifer hits the sign up button, and then John immediately after that hits the sign up button. All right, so we have Jennifer's record, but if you just saw, Jennifer's record got Jennifer's record got overwritten by John's record, and this is an extremely bad problem to have, right? Because again, you don't want your data to be overwriting other people's data, and this happens again because these users are accessing the app basically at the same time, and there are conflicts now. So that is again a very bad problem to have. So how do we solve that problem? Well, enter lock service. So let's just create a lock, and we'll call it lock. We'll give it the variable name of lock. And then again, we need to access the lock service parent class. So if we hit the period button, again, we have 3 different locks that we can use. And we went over these in the last episode. The user lock would not make much sense in this scenario. And document lock technically does make sense because, again, we're trying to lock down the document. However, this is a standalone script, so it's not going to make sense in the context of a standalone script because, again, if we try to call getDocumentLock, this script is not going to know which document we are talking about. So we have to use the method getScriptLock, which will work perfectly anyways for our use case. Great, so this is just getting all of the background, the metadata of the lock. Now we have to actually obtain the lock. So to do that, there are 2 separate methods that we can use. We can either use tryLock or waitLock. So these 2 methods are basically exactly the same. They have the exact same performance. However, the only difference between these 2 are what does it return. So the tryLock method returns a Boolean. If it gets the lock, it will return true. If it fails to get the lock, it will return false. WaitLock, again, same performance. However, if it gets the lock, it won't return anything. Like you can see there, it returns void. However, if it fails to get the lock, it will error out. So these 2, you would want to use one or the other based on your use case, how you want to handle not getting the lock. But I'm just going to use tryLock for now. All right, so it also requires a parameter to be passed in, and this is the timeout in milliseconds. So again, this is super helpful because if somebody else has the lock, or they have locked down the script, and you're trying to get the lock, right? You're trying to access the code. However, they have the lock for a very long time. It's good just to have a timeout because you don't want to be trying to get the lock indefinitely or for a very long time. You want to say, stop trying to get the lock and then tell the user, hey, the network is busy or the database is busy. Try again in, like, I don't know, a couple minutes, right? So this is just a really good parameter to pass in, but let's just say 5 seconds. We'll try to get the lock for 5 seconds. All right, so let's look at another method, and that is hasLock. This is very self-explanatory. If you have access to the lock, it will return true. If you do not have access, it will return false. Great, so let's just wrap that in a conditional. We'll say if hasLock, then we want to run this section of code right here. So everything that I'm wrapping in this conditional, in this if statement, is what the code that we are locking down. We are only accessing this code one user or one person, one execution at a time. Great, so there's one more thing that we have to do before we run this, and that is after we are done executing all of the logic, we have to now release the lock so that other people can use the lock to run this section of code. And to do that, it's extremely simple. We'll say lock.release lock. Awesome. Now, if we save it and let's refresh these web apps just so that we can get the reflected, or we can reflect the changes that have been made in the code. All right, so let's say now, let's pick 2 more users. Let's say Peter is trying to access it, and then also let's say Courtney is trying to access. So again, Peter and Courtney are trying to access the web app at the exact same time. Let's say Peter signs up and then Courtney signs up almost directly after that. We'll get Peter's record, and then we will get Courtney's record exactly 3 seconds after that. And it shows here in the timestamp 4 seconds. That's probably just because there's a little bit of time that passed just getting access to the spreadsheet or getting the range. But anyways, that's not the point. The point is that now both records have been added to the Google Sheet, which is exactly how we want it to operate. We don't want anyone's data overwriting anyone else's data. So that is, again, pretty dang cool that that works like that now. And that is because Peter first got the lock, right? Peter got the lock once he ran this, and then when Courtney's runtime, when Courtney's execution happened, she had to wait until Peter had released the lock before she got the lock, and then she could run this. So I want to make this point explicit. I want to make this, I want to drive this point home, and the way I'm going to do that is I'm going to now say console.log, and I'm going to just log a new date, a timestamp, and then I'm also going to repeat this statement up here. Great, so let's say now I'm going to refresh this page, and I have, by the way, our Stackdriver logs running right here. So let's say that I'm going to access this app, and I'm going to be named Robert. And if I triple click now this sign up, watch what happens. So I'm going to click, click, click. And if we go into our project, or let's actually go into our Google Sheet first. And actually, I had to do one more thing because I need to try to get the lock for let's just say 10 seconds now. So let me try this again with let me get rid of these two records. All right, so let's try this again. So we have Robert right here, and if I do a triple click, let's go into our database. All right, so we have the first click, and then we have now the second click, and then we should now get Robert a third time. Boom. So there we go. We have all three records. Let's go into our project executions, and let's refresh the page. Great. So as we can see, this is the one that we just ran, I believe. All right. So we have these three executions of the code, right? We triple clicked it. We have these three executions of the code. And as you can see, all of them initially ran at 1647 and 8 seconds. So all of them hit this line of code at 8 seconds long, right? But now if we look at how long after we tried to get the lock, when this second line of code ran, let's take a look at that. So this was the first click, right? So we ran that second line of code basically instantaneously after this first line of code was run, right? There's no difference between 8 seconds here and the 8 seconds here. The second time, so the second click, it ran 3 seconds after we clicked it for the first time, or after. So again, we were waiting for this lock for 3 seconds, and then after the first click released the lock, then we got the lock, and then we ran to this line 14. And then finally, the third click, it had to wait for 6 seconds, right? So it tried to get the lock. It tried to get the lock, but then there's also the second click that was also trying to get the lock. Once the second click got the lock, then it ran for 3 seconds, and then released the lock, and then finally the third third click got the lock, and it ran this line of code, and then again that took 6 seconds after. So it took 6 seconds to get the lock. All right, guys, I hope that was helpful. I hope you have a better understanding of lock service and how it could be useful for your web application as well. If you liked it, don't forget to hit the like and subscribe buttons, and I'll see you in the very next episode.